Good evening students, this is Siddhav Sakalkar here and we'll be learning the topic of fixed beam. Now as I already taught you on Saturday, the sums which we did too, there was a lot of confusion, but it was during the latter part of the sum. The initial steps of shear force and bending moment will remain the same. So here is the sum which I have drawn here. Now you can see AB as a fixed beam. You have to analyze the sum. As I said earlier, analyzing the sum means you are going to find the moment at A and moment at B. Now you can see AB is a fixed beam. There is a force of 10 kN acting and 20 kN acting at 2 meter from the left end and 3 meter from the left end. You are supposed to analyze the given fixed beam and then draw the shear force and bending moment diagram. Now shear force and bending moment diagram, this is the secondary part. The first part which you are supposed to do is find the fixing end moments, which constitutes 98% of the problem. Now as I already taught you, the step number 1 which you will be doing is that considering beam AB as a simply supported beam. If you consider beam AB as a simply supported beam, that means you remove the fixed supports. When you remove the fixed support, what remains is that hinge and roller supports, means just the normal simple supports which cannot take any deflection. Now when you consider beam AB as a simply supported beam, then step number 1 is you are supposed to find out the support reactions, mean RA and RB, means reaction at A and reaction at B, you are supposed to find out. Now you know the sign convention which we take is clockwise positive. I have drawn the sign convention here, I will again explain it. I have drawn a dotted line here, and clockwise positive means summation moment at B is equal to 0, means when you are taking moment at point B, all the forces coming from left to right side clockwise will be positive. Ultimately anti-clockwise becomes negative. Now let's see it, how it comes out to be. Summation moment at point B is equal to 0 means moment at this point is equal to 0. So there are three forces which is acting. First, RA is acting clockwise over a span of 6 meter. So it comes RA into 6 meter. It is going clockwise towards point B. So it comes out to be RA into 6. Then this 10 kN is taking anti-clockwise over a span of 4 meter. And after that, this 20 kN is again going anti-clockwise over a span of 3 meter. So you get the value of RA to be 16.67 kN, which I have written here. After that, now there is only one unknown remaining, which is RB. Now the step which you do is that summation f of y is equal to 0, means summation means addition, f means forces, y means direction, means addition of all the upward and the downward forces you are going to do, which comes out to be plus RA plus RB minus 10 minus 20, which you can see here, RA plus RB minus 10 minus 20 is equal to 0. In this way you get RB to be 13.33 kN. Now you have got the values of RA and RB, the same which is there in my notes. Now step 2 also I taught you on Sunday, which is after this you are going to draw the bending moment diagram. Again, for drawing the bending moment diagram, you are going to consider this step, which is very important, that beam AB is a simply supported beam. So what are you supposed to find out? Since AB is a simply supported beam, means moment at A and moment at B is going to be 0, because hinge and roller supports cannot take any moment. So you are supposed to find out moment at C and moment at D. This 2 points which is already plotted here, the same I taught you on Sunday. How you, again sign convention is clockwise positive. First is moment at C. Moment at C, if you take from left to right, what forces are acting from point A to point C? Only one force, which is RA, which is taking a clockwise moment of 2 meter till point C. So it comes out to be plus RA into 2, which is 33.34 kilonewton meter. Do not forget to write the unit, students. After this, you will take moment at point D. Okay, if you see from A to D, what forces are acting, students? Force RA is acting clockwise 3 meter, RA into 3, which is plus RA into 3, and this 10 kilonewton force is taking an anti-clockwise moment of 1 meter. So plus RA into 3 minus 10 into 1 comes out to be 40 kilonewton meter. What you will do is that next, you are just supposed to plot these values and draw the bending moment diagram, so that you almost finish 40% of the problem. So I'm going to tell you how we draw the bending moment diagram is that now you are drawing the bending moment diagram, but you are considered, do not forget, you have considered this beam AB to be simply supported beam. Means load at support A is 0 and load at support B is 0. So this bending moment diagram is going to start from 0 point of this and end at 0 point of this. Now, moment at C is what? 33.34. If you see between A to C, there is no force acting. Between 2 point loads, when there is no force acting, then in bending moment diagram, it is shown by a inclined straight line. So I draw a straight inclined line from this A till this point C. After this, what is moment at point D? 40 kilonewton meter. So after plotting C, we are going to plot D, which is almost 7 kilonewton more moment. So this here I plot a point 40 kilonewton meter. This is point D. Again, students, between C to D, there is no load, UDL, no force acting. Again, it will be shown by a inclined straight line, students. Sorry. So from C to D, I have shown an inclined straight line. And after this, you started from A, you ended at B. It is not required to be shown that moment at A is equal to 0, moment at B is equal to 0. In this way, you go on to finish your bending moment diagram. Okay, students, in the next video, I am going to show how to find the fixing end moments. So just this diagram, how we are going to draw this trapezoidal diagram and how we are going to merge these two diagrams to see what is our fixing moments to be. So after this, students, a small just step is remaining, which I will post in the coming time. Okay, thank you very much.